Alright, well today we're going to talk about factoring trinomials by the ABC method. Thanks to my friend Bobby, I've renamed this the ABC method as opposed to the AC method. If you search the internet for methods of factoring trinomials, then the AC method is a lot of times associated with what I call the grouping method, and this is a little different. And so I'm going to call this the ABC method of factoring. Okay, and don't want to do that. Let's see here. All right. So here's what we're looking at right here, our pre-knowledge of the things that we need to know to be able to do the AC method. Okay. So I want to talk to you first about the adding and subtracting of signed numbers. Okay. So we know here's some bullet points right here. So we know that a positive number plus a positive number, we always get a positive number. An example of that is 2 plus 3 is 5. Revelation of the obvious. That a negative number plus a negative number is equal to a negative number. Okay. Negative 4 plus negative 6 is negative 10. You always get a negative answer. One way of looking at that is if you have a bill and you get another bill in the mail, there's really nothing great news about that. You're further off in debt, so you're adding the absolute value and it becomes negative. And then the case where you're adding a positive and a negative number, or a negative plus a positive number, regardless of the order that you're adding those in, you always subtract their absolute values and you take the sign of the larger absolute value. So examples of that is negative 7 plus 3. If you owe 7 and you have $3, basically you're owing $4. And then if you have 8 and you owe 5, of course to get 3 we subtract 5 from 8. It takes on the sign of the larger positive. 8 is the larger absolute value, so this sign is positive in this problem. 7 minus 3 was 4. That's how we got the 4 we subtracted, and it took the sign of the larger absolute value. Negative 7 has a larger absolute value than 3. A lot of this you may not need to go through if you're up on your arithmetic. You could move on further into the video and find where we start the factoring by the ABC method, but I'm going to go through these preliminary things here. Okay, next screen. Multiplying, and I'm afraid you're not seeing all of this. I wish there was. Let me see. I think I can move this up. All right, there we go. All right, so multiplying signed numbers, and here's a few facts about that. If you take a positive number and you times it by a positive number, the answer is always positive. Example, 2 times 3 is equal to 6. If you take a negative number and you times it by a negative number, you get a positive answer as well, or an even number of negatives in a multiplication problem. Here we have 2 numbers, there's 2 negatives, that's even. Then you get a positive answer. Or example, negative 4 times negative 6 is positive 24. Now this is different than when we added. When we added negative numbers, the answer was negative, but when you multiply 2 negatives, you get a positive. That's a lot of times confused. All right, and the third scenario is if you have a positive times a negative or a negative times a positive, regardless of the order, then you're going to get a negative answer. And again, if you use the rule for the odd number of negatives in a multiplication problem, 1 is odd, then the answer is negative. Okay, 2 examples here, negative 7 times 3, negative 21, or 8 times negative 5 is negative 40. But we need to be able and feel comfortable with knowing what sign the answer is going to be when we multiply a variety of signed numbers. Okay, so I want you to answer these 4 questions for me. What can you tell me about 2 numbers if 1, their product is positive and their sum turns out to be positive? Tell me everything you can tell me about those 2 numbers. 2, if the product of those 2 numbers is positive and the sum of those 2 numbers is negative, what can you tell me about those 2 numbers? If those 2 numbers, if the product is negative and the sum is positive, and then if the product is negative and the sum is negative. So I'm going to stop the video and let you answer those questions. Class, I'd like for you to put that in your notes. All right, coming back to that, well, if the product of 2 numbers is positive, they have to have the same sign, and if their sum is positive, they would both have to be, and I'll just use a plus sign for positive here. Both numbers are positive in this case. Okay. If the product's positive, again, I know the signs have to be the same, and if their sum is negative, then we know that both would have to have a negative sign, or both numbers in this case are negative, and I'll use the subtraction sign for negative. If their product is negative, well, the only way to get a negative between two numbers is if one was positive and one was negative. So we know we have different signs here, and their sum is positive. Well, we know the sum, when you add a positive and negative number, you really subtract and you take the sign of the larger. So here, the sum being positive tells me that the larger number would have to be positive, and there's a smaller number here also. The smaller number would have to be negative. Okay? And in 4, when their product is negative, again, I know I have one positive, one negative. Their sum is negative. I know here that the larger number had to have a negative sign because the answer of the addition problem took on the sign of the larger, and then that's a smaller number. Larger and smaller, try to fit those in there, had to be positive here. Goes without saying. Okay? All right. Some more things. Signs in fractions. If a fraction is negative, that negative sign can be located anywhere in the fraction. So here I've shown you that here the negative is with the numerator, here the negative is on the fraction bar, and here the negative is in the denominator. These are all equal, and for the AC method we would choose for the negative to be in the denominator when there's only one negative. So for our example we would be using the last one, 1 over negative 2. And if a fraction has two negatives, like if the top and the bottom are negative, of course it could be on the numerator in the fraction bar or the fraction bar in the denominator. Nonetheless, these all have two negatives in them, and that would turn out to be positive. It would be like multiplying two negatives. If there's two negatives, the answer turns out to be positive. If you divide a negative by a negative, you get a positive answer. And for the AC method, we would want to write that as positive 1 over 2. Okay, some other things. If you're multiplying two like binomials, when we multiply two binomials that are like, and for that I want to just explain a little bit that you have x to the first power plus a constant and something with x to the first power plus a constant. We'll call those like then for this purpose. We'll use the FOIL method to give us the answer. So when we're using the FOIL method, we take first times first. So it's 3x times 2x, and that would give us 6x squared. And then we'd do the outside, so it would be 3x times positive 5, and then we would add to that the inside, 2 times 2x, so we have 15x with the outside, 4x with the inside. 15x and 4x is 19x. And then last times last, positive 2 times positive 5 would give us 10. Okay, now as you can see, that is in what we call standard form, or the form of a, which here is 6, x squared plus bx, which would be positive 19, would be b, and then plus c would be, the c number would be 10. All right, now, if that's how we multiply two binomials of like binomials, then so when we factor or unmultiply a quadratic, or a y equals ax squared plus bx plus c, something that's a I don't know that the y equals would be here right now. We're just talking about things that are, so it wouldn't have that y yet. So we just, of the form ax squared plus bx plus c. I just wrote that right here. Okay, we expect to get two binomials of the same type with x up front and the constant in the back. So if we took 6x squared plus 19x plus 10 and we wanted to factor it, remember that if I told you to factor 15, one correct answer would be you would give me 3 times 5. Okay, so when you factor something, you write it as a multiplication problem. So here's our multiplication sign down here, and I know if it's a trinomial, then it's probably going to be the product of two binomials. Now what I need to know is, what are the numbers? I expect there to be an x up front and a constant in the back with both binomials, and I expect there to be two binomials. We've just shown you we multiplied two binomials and we got this trinomial. So if we were going to factor this, we would expect to get two binomials. And then the only mystery of this is what are the numbers that go up front? Well, I can just look up there at my problem and see that 3 would have to go here, and 2 would go here, and this would be 2, and this would be 5. And I'm just looking up here at our problem that we worked a minute ago. Well, again, we expect two binomials and we expect an x up front, so really the only mystery is what are the numbers that accompany that. And the ABC method is going to give us those numbers, and we have to know to put them in the form of two binomials with an x up front. Okay? All right, well, let's go to our first example, or actually not the first example, but the rules that we have to adhere to when we do the ABC method. Well, the first rule is this, that you must take out any common factor before you start factoring. So if you had 6x squared plus 12x minus 3, then that must be written as, notice they all have a factor of 3 of them. Take the 3 out, and that would leave you with 2x squared plus 6x. And this should not be 6x, this should be 4. I thought I had this corrected, I don't. So 4x minus 1. And then we would use the AC method to factor this trinomial right here. What we'd have to remember is when we get to our answer, we'd have to annex the 3 that we took out to start with. So what you need to know is that the ABC method will not identify a common factor for you. It will, what I call, whitewash that common factor in the process. So you need to take it out to start with and annex it on the end. Rule number 2. If the leading coefficient is negative, you treat it like a common factor. So if we had a trinomial that started with negative anything, then we want to take that sign out. So to factor out a negative, all you do is put what you had in parentheses, change all the signs, have a negative out front. Remember, now when you multiply by a negative, the signs change, so when you factor a negative out, well, they have to change back. So we just change them and put a negative on the outside. And the third thing is that if a fraction has only one negative sign, like we said to start with, that we want that negative to be in the bottom. So these are things that we need to follow as we go through here. Now to our first example. We're going to factor 6x squared plus 7x plus 2. And step 1 would be to identify what a, b, and c are. So the a is the coefficient of x squared, or 6. The b is the coefficient of x to the first, and of course we're going to take the sign with it. Of course 6 was positive, so this is positive 7. And then the c number is the constant on the end. Again, taking the sign with it, of course 2 is positive without putting any sign, so it stays positive. Well, step 2 would be to find the numbers that will solve these two equations. And here's where we get our name. And you notice that we're using all the 3 letters A, B, and C. But what we want is, we want to find two numbers that will multiply to be whatever A times C is for our problem. And the same two numbers, without changing anything, they have to add together to be the B number. So for our particular problem, then we're looking for two numbers that will multiply to B. Well, our A is 6 and our C is 2, so 6 times 2 is positive 12. So we're looking for two numbers that will multiply to be 12, and at the same time, those numbers have to add up to be the B number, which is 7. Okay, now this sometimes takes a little time to think about it, but you know, this one's sort of easy to start with, so you probably came up with the numbers already, and that's going to be 4 and 3. So positive 4 and positive 3 multiply to be positive 12, and they add to be positive 7. Or if we have a product that's positive and the sum is positive, that would be two positive numbers. Okay, continuing, the next step would be to put them over the C number. Okay, so for our C number is 2, so I'm going to put these over 2, and I'm going to pretend now that these are two fractions, and I'm going to pull this out as fractions, and I'm going to simplify them. Okay, to simplify 3 halves, well, it doesn't simplify, I just get 3 over 2. 4 over 2 would simplify to be just the number 2, but for our purpose, we don't want to take that any further than 2 over 1 because I need a top and a bottom number. So anytime it works out to be a whole number, we'll leave it as itself over 1. Okay, now when we started this, I told you that we understood that if we factor a trinomial, we're going to get two binomials with an x up front and a constant in the back. So you start writing your answer by writing that out, and then here's how these numbers go in our answer. This top number of our first fraction goes up front with the x, that's your coefficient of x, so a 3 goes here. The bottom number in this fraction is going to be the constant in the back. Now, you need a sign, so since 2 is positive, I write plus 2. Okay? Go into this one. This one goes up front with x, the top number goes with x, so that's 2x, and the bottom number is the constant in the back. And we always do this, and we always have to take the sign of whatever that is. It's positive, so it is plus 1. So to factor 6x squared plus 7x plus 2 by the ABC method, it gives you 3x plus 2 times 2x plus 1. Well, just to check it, let's go ahead and FOIL this out. First times first would give us 6x squared. Outside, 3x times 1 is positive 3x. Inside, 2 times 2x is positive 4x. And last times last, 2 times 1 is positive 2. And if you add the like terms in the middle, you will get what we started with, 6x squared plus 7x plus 2, factoring by the ABC method. All right, let's do another example. Don't expect that you're going to get this the very first time we do it, so I want to show you several of these. Okay, so for this problem, we know that we're looking for two numbers that will multiply to be AC. Well, our A is 15, and our C is negative 2. Don't forget the sign. And so that would give us negative 30 when we multiply those two numbers, or that's A times C. And at the same time, I'm looking, these same two numbers have to add up to be the B number, and the B number is positive 1, so they have to add up to be 1. Now remember what we said about two numbers. If their product is negative and their sum is positive, we have one positive and one negative number, and that this takes on the sign of the largest, so I know the larger the number is positive, but 1 is really not what they add up to be, it's what they subtract to be, because when you add a positive and negative, you actually subtract their absolute values. So again, when I'm trying to think of these two numbers, I have to keep in mind that 1's not what they add up to be, it's what they subtract to be, and the larger of those two is positive. So thinking about numbers that multiply to be 30, that subtract to be 1, it's going to be 5 and 6. So I'll put 5 and 6 in here. And I'm going to have to put a negative on one of these numbers. Now, if I look at the multiplication problem, the negative 5 times positive 6 is negative 30, or positive 5 times negative 6 is negative 30. So the multiplication problem is sort of indifferent to where the negative goes. But in the addition problem, there's only one place that you can put that negative, and it turned out to be positive 1. And that negative would have to be on the 5. So it's the addition problem that decides where the negative goes. Okay? The next thing in our step is to put it over the C number. So I'm going to put both numbers over negative 2. And then I'm going to reduce these fractions. Remember now we said if there's two negatives in a fraction, it becomes positive. So we write this as positive 5 over 2. And here I'm going to reduce this. It could reduce to negative 3, but I need to keep it as a fraction. So I'm going to write it as 3 over 1, or it could have been negative 3 over 1, but remember where we want our one negative to be. If there's going to only be one negative with this AC method, we choose for it to be in the bottom. So 6 over negative 2 is going to reduce to 3 over negative 1. And then 5 over 2 is going to become 5x positive 2 plus 2. 3 over negative 1 is going to become 3x minus 1. And if you multiply those together, you get 15x squared plus x minus 2, factoring by the ABC method. Okay, let's take a look at another one. All right. Okay, so here we're looking for two numbers that will multiply to be A times C is going to be positive 30. Well, 30 keeps popping up, it seems. And those same two numbers have to add up to be the B number, which is going to be negative 22. Positive product, negative sum, two negative numbers. So I'm looking for numbers that multiply to be 30, that when I add them up, they're 22, and they actually add up to be 22, and they both have to be negative. I'm not coming up with numbers all that quickly. Let me go through the factors of 30. Well, 1 times 30 is 30. Those are two factors of 30. And then 1 plus 30 is 31. That doesn't work. 2 times 15. Those are two factors of 30. 2 and 15 add up to be 17. That's not 22. 3 and 10. Well, that multiplies to be 30. and that adds to be 13. That doesn't work. 4 doesn't go into 30. 5 goes into 30, and it goes in there 6 times. That adds up to be 11, and then if I go one bigger than 5, I'm back 6 again, and of course there's no more factors of 30. I've looked at all the pairs, and none of them add up to be 22. So I'm going to conclude that this is not possible. Now, I put this one in here because you might get some that are not possible, and odds are that if you just make one up randomly from out of your head, it probably won't factor with the ABC method. So this one's not possible. I've exhausted all the factors of 30. None of them add up to be 22, so it's not possible. Okay, all right, so I've got several here in a row that I want you to try. I'm going to go ahead and stop the video and give you a chance to work this one. All right, working through this one, we know we set up our our equations, a product and a sum. The two numbers have to multiply to be what our A times our C is, and that would be positive 4 times positive 5, or 20. And the same two numbers have to add up to be positive 12. I know I have two positive numbers, and as I think about this, it's going to be 10 times 2. That's going to make both of them true. It's your job to come up with those numbers. We put them both over positive 5, and we reduce. This is going to reduce to 2, or 2 over 1. And then 2/5, it just stays 2/5. 2 over 1 becomes 2x positive 1, or 2x plus 1. 2 over 5 becomes 2x plus 5. Okay, let's try the next one. Pause the video. Let's give you time to work it. Okay, setting up our two equations. The product has to equal our A times our C, which is 3 times negative 12, or negative 36, and the sum has to be the B number, positive 5. Since I have a negative product, I have to remember that they actually subtract to be 5. So two numbers multiplies to be 36. When you subtract them, you get 5. That's going to be 4 and 9. This is your responsibility to think through the factors of 36. Now, one of them's got to be negative. The multiplication problem doesn't care which one's negative. The addition problem will care. It will matter. And the negative would have to go on the smaller number for the difference for the answer to be positive. So we put the negative with the 4. So it's negative 4 times 9, which is negative 36. Negative 4 plus 9 is 5. We put it over the C number with the sign, negative 12, and then we reduce these fractions. Negative over negative, positive. 4 over 12, 1 over 3. 9 over 12 reduces to 3 over negative 4. 1 over 3 becomes 1x plus 3. And 3 over 4 becomes 3x minus 4. Okay, next problem. Give you a chance to work it. Alright, so our product has to equal 7 times negative 3, or negative 21, and our sum has to equal negative 20. Well, with the negative product, I know the numbers subtract to be 20, and that's going to be kind of obvious. It's 21 times 1. When you subtract 21 and 1, you get 20. 21 and 1. The largest one's got to be negative, so it's got to be negative 21 for the sum to be negative 20. Put it over the C number, negative 3. Reduce two negatives, make a positive. 21 over 3, 7, or 7 over 1. And then 1 over negative 3. It's not going to reduce. This becomes 7x plus 1. This fraction becomes 1x minus 3. Next problem. Give you time to work it. All right. So our product has got to equal 3 times negative 10, or negative 30. And our sum has got to equal the B number, negative 17. With a negative product, I know the numbers actually subtract to be this. I think this should be something else here. Let's see. I think this needs to be positive, and this is positive. Okay, so let's go back and change that to positive and positive, because I can look at that one and tell I messed those signs up. So apologies to you. Both of those should have been positive for this one to work out. Okay, so two numbers that multiply to be positive 30 that add to be positive 17. That's going to be 15 and 2. 15 and 2. And then we're going to divide by the C number 10. And we get, dividing by 5, 3 over 2, and 1 over 5. And this is going to become 3x plus 2. And this becomes x plus 5. And that will multiply to give us 3x squared minus plus 7x, 17x plus 10. Next problem. Okay, go ahead and take time to work this. Okay, so our product has to equal what A times C is for this problem, which is 30. It's been coming up quite a few times here. And they have to add together to be negative 9. Well, it'd have to be two negative numbers. And if you remember earlier, we went through the factors of 30. 1 and 30, 2 and 15, 3 and 10, 5 and 6. None of them add up to be 9. Not possible. Okay, next problem. Factor this. Now, one of the steps that we should have been doing from the start that I haven't mentioned was that you always have to take out a common factor first. So let me remind you before you get started on this problem that that's something we should be checking every time. So let me stop the video. Okay, so hopefully you notice that each of these numbers had a factor of 2 in it. So we can take the 2 out, and we have to take it out. And that's going to leave us with 8x squared plus 2x minus 3. So we're going to factor this with the AC method. So we have two numbers that multiply to be negative 24. And at the same time, they add up to be 2, but we know they actually subtract to be 2. Well, that's going to be 6 and 4. Multiply is to be 24, subtracts to be 2. To make the addition problem work, the negative would have to go on the 4. We put those over negative 3. We reduce. This becomes 2 over negative 1, and this becomes 4 over 3. We get 2x minus 1 times 4x plus 3. Now, what we have to remember is that since we took this common factor out to start with, that's part of, I don't know where the 3 came from there, that is part of factoring this. Okay? So, annex the 2 onto the answer. Now, if we don't do that, let's work this out without taking the common factor out so you can see what's going to happen. That's why you have to take it out. Because what you'd get here would be 6 times 6 is 36, carry 3, you'd get 96. And it'd have to subtract to be 4. Okay? So we'd have 12 and 8 would multiply to be 96. 12 minus 8 would be 4. We would put the negative on the 8 and we'd put them over negative 6. This is not the right way to do it, but this is what will happen if you miss the common factor to start with. This is going to reduce to 2 over 1. This is going to reduce to 4 over 3. And it would give you the same answer here, but you wouldn't get the 2. It's not going to produce the 2. It's going to produce this if you forget the common factor. So you have to take that common factor out to start. Okay? Well, it looks like that's the end of the video. We'll be making an assignment. Thank you for watching.